Okay, now that is done. I would like to give one example. That will be how to balance redox reactions that are having oxoanions. Yes, redox reactions bearing oxoanions, acidic medium. Okay, redox equation in acidic medium. I would like us to look at this oxoanion. Oxoanion of this sort is an oxoanion, an anion that is oxygenated, sort of. Can also have this oxoanion. Can actually have this oxoanion. We can also have this oxoanions, and so on and so forth. Okay. Now, these are oxoanions, and then how do we balance this redox reaction if acidic medium is concerned? What do we do in these reactions? And we just do very basic things here. Now, okay, supposing we know that MnO4 minus, that's what we had in the first one. We're just going to do these three straight examples, and then you go to a link and you go to where we have this problem solved. Past question, WAEC past questions, GCs, NECO, UTME, and even post-UTME, where these questions have been asked. A series of these questions has been asked by exam bodies. So we have it, go to the link and then see how we trash these questions. Okay, so coming over here, but I'm going to do this in this video. This is manganese 7. Remember what we did in the other video when we were talking about the rules of oxidation states. Okay, where this is going to be 7. How do we know it's 7? Already I know that there is a rule for oxygen which is -2. This is not a peroxide. So since it is not a peroxide, it's -2. So -2 times 4 is -8. Keep -8 somewhere. Now what will be here? If you add it with -8, you have -1. That is +7. So +7 minus 8 is -1. Okay, then you should know that the most stable oxidation state of manganese, since it has variable oxidation number, is Mn2+. Mn2+. I'm going to do this video on metals, so you know metals, how they reduces to their stable oxidation number. This manganese has changed from 7 to +2. That is reduction. The reduction, the loss of oxygen. So, but if I'm trying to balance this redox reaction in acidic medium, that means this side should be carrying hydrogen ion. Okay, this side should be carrying hydrogen ion. And that hydrogen ion is as a result of water molecule in the product. So the product, which is always at the right hand side, should bear a number of water molecules that should be able to, that oxygen in the water molecule that should balance this oxygen in the oxoanion. Okay, suppose I want to do the first step. First step is that I'll try to balance this oxygen by saying, okay, I have MnO4 minus, here I have Mn2+. Actually, there has been a reduction now. Okay, so to balance this oxygen here, 4 molecules, just 4. That's what we have here, 4 H2O. The reason for adding this H2O is because we are balancing this reaction in acidic medium. Because we're going to, from this H2O, have a protonized form of hydrogen. So how many protons are we going to have here? We have 4 here, so 4 times 2 is 8. So in the next stage, I'm going to try to balance it. Oxygen is balanced, but this side does not have enough hydrogen ion here. So what we do is 4 times 2 is 8. So we have here 8H+. Will now be in this. So this is going to be in acidic medium because of this. So we have MnO4 minus. Here we have Mn2+ plus 4H2O. Why we actually added 4 molecules of water is because of oxygen. And since we are balancing this in acidic medium, that means this is from acid. Okay, so it seems as if this equation is balanced atomically. Yes, the equation is balanced atomically, not ionically. Atomically, that's that we have H8 here, we have 8H here. Mn is 1, O is 4, O is equal to 4. Then the charge, what we have here is +1 multiplied by 8 plus -1. That's what we have here, which is plus 8 minus 1 is plus 7. Here, the total net charge here we have here is plus what? 2. So what is the difference of charge on both sides? Is 5. So what do we do to balance that equation? Is that we're going to add that difference here as 5e minus plus 8h plus mno4 minus, and on the other side we have what? mn2 plus 4h2o. Okay, let's say we are balanced. Now we have minus 1 here, multiplied by this 5 more here. We have here 8 here, multiplied by plus 1 here, we have plus minus 1 here. So here 5 times minus 1 is minus 5 plus 8 minus 1. Minus 5 plus 8 is plus 3. Plus 3 minus 1 is plus 2. So this side is plus 2. This side will definitely be plus 2. Here the only charge we have here is plus 2 plus 4 multiplied by 0. Remember the rule here. Here is what? Plus 2 plus 0. Plus 2 plus 0 is still plus 2. So atomically, this equation is balanced. And then ionically, or by charge, this equation is also balanced. Okay, you can pause the video and still try and see if you can do this at home. Very simple. The same thing, the same way you do this, the same way you do this, you can still do this. Okay, I'll quickly take you on that. Quickly. And then, if you want to get more of this, you go to our past questions, link on our past questions, where we solve as much of these examples. So here we have CR2O7. This is according to what we did in the other rule. If you solve this, you now find that the oxidation state of chromium here is plus 6 here. So delta is going to reduce to its stable oxidation state of plus 3. That is chromium plus 3. So what you do to balance it? First, you are balancing this first. So what we need to balance this anion is add, since it's an acidic medium, is add a number of water molecules here that will be enough to balance 7 atoms of oxygen here. So in that step, I'm going to have this Cr2O7, 2 minus, here is 2Cr3 plus. So I have 2 here. So what goes here is what? 7 molecules of H2O, just because of this 7 oxygen. That's why you're doing that. So in the next aspect then, since here I have 7H, which is 7 times 2 is 14. So here will be what? 14H plus, now, plus Cr2O7, 2 minus, and here we have 2Cr3 plus 7H2O. Okay, it seems that everything here is atomically balanced. What of ionically balanced? Here we have plus 1 here, times 14 is 14. 14 minus 2 is 12. So, but the total net charge here is 3 times 2 is 6. So 12 here, 6 here is not balanced. The difference is 6. What do you do here? That 6 will go as an electron loss. So this side is here, you're going to add, not this side. So we add that 6 electron here to balance it. Then any other thing will be sacrosanct. Every other thing will remain the same except the 6. So the difference between this one and this one is only 6 to balance the charge. So as this 6 has entered here now, every other thing remains the same. So I'm going to add this here as 14H plus Cr2O7, 2 minus, what goes here? 2Cr3 plus 7H2O. Let's see if the equation is balanced both sides. Here I have 6 minus 1. This minus 1 here, multiply by 6 plus 14, multiply by plus 1 plus minus 2 is equals to, let's see, they go to the other side, you have 2 here multiplied by plus 3 plus 7 here multiplied by what? 0. This gives me minus 6 plus 14 minus 2, which is equals to plus 6 plus 0. Minus 6 plus 14. Minus 6 plus 14 is going to give you what? 8 plus 8 minus 2, which is equals to plus 6 plus 0 is plus 6. So plus 8 minus 2 is plus 6. So both sides of the equation is what? Balance. Balance. You can pause the video and do these two, or you go to the link and see where more questions have been solved regarding balancing redox reactions in acidic medium. Okay, there's one more thing I'm going to do here so that from there we can be able to know how two of these redox, because this is just one way redox equation in acidic medium. We have two way which involves reduction and oxidation at the same time, and that is also in acidic medium, bearing oxo anion as the reduction side. I think I'll give you two or one example on that before we call it a day on this topic. It is very, very important. I'm going to just solve 2 problems here, and then for more problems, you go to our link to see if you can see more of the past questions on WAEC, NICO, post-UME, UME past questions on this topic. Okay, we'll look at 1 or 2 examples on redox reaction involving reduction and oxidation. Involving reduction and the oxidation. Supposing we have MnO4 minus plus ion, it reduces to this one oxidizes to this. Okay, you can pause the video and answer the simple question here. In the reaction, which is the oxidizing agent? Pause the video and answer the question quickly. Okay, now, which is the oxidizing agent depends on what you have assigned individually as their oxidation states. Try to know that the oxidation state of Mn here is +7. This is 0, remember rule number 1. This is +2. This is +3. So now, actually between MnO4 minus and ion here, which one has reduced? The one that has reduced between the both of them in the reactant is the oxidizing agent. Manganese here was 7, now it has reduced to +2. Iron was 0 here, now has oxidized to +3. So the reduced one is the oxidizing agent. So MnO4, this is the oxidizing agent, this is the reducing what? Agent. But from the reaction, you are now discover that from here to here is reduction. Then from here to here is oxidation. So this reaction entirely is redox reaction. Redox reaction. Okay. Now we have to have this equation. We have the equation. We start from oxidation first. We have this actually reduced. Sorry, oxidized. So this here we have 0. You have +3. What do we do to have the both side balances to add 3 electrons here? So now you have -3. So everything becomes 0. So here will be what? Equation 1. Okay? Very simple on that. Make sure that if you gain this electron going backward, it will reduce. So the equation can be balanced. So in the other one, you have MnO4 minus, which actually has reduced to manganese 2. What do you do as far as oxygen is concerned is to add molecule of H2O. At the same time, come this side to protonize it. How many hydrogen go there? 4 times 2, 8 hydrogen ion. Okay, now check the difference. Atomically, once you do this thing about water and hydrogen, the equation is balanced. Basically, if you're asked to balance this reaction in acidic medium, once you have done this equation is balanced, and we'll try to see if the charges are balanced. See what you do next. If it's 8 minus 1 is 7, there is only charge here is +2, so difference is 5. So make sure that 5 comes in here at the reactants. Just like this one is at the product, this one will be at the reactants. How many difference in the electron is what? 5. E minus. Okay. Okay, that's what you have it. So you have to check, let me call this equation 2 now. Okay? So that from electron gain here and electron you lose here, to know what you're going to do to make sure they both are the same. So this 5 is going to come up here, go here. This 3 is going to come here and go this side. Okay, now that we have this, if this 5 goes here, it will be what? 5Fe. Here will be what? 5Fe, 3 plus, here is 15E minus. Let me call it equation 3. Here will be what? 15E minus plus 3 times 8. 3 times 8 will be 20, I think 21. H plus 3MnO4 minus. Here we have 3Mn2 plus 12 H2O. Okay, 24 right? 24 rather. Okay, 24 rather. Okay, 24. Good. So this is going to be equation 4 now. So we have the overall reaction. We're going to have this now to cancel. So the reactant will be 5Fe plus 24H plus 3MnO4 minus. Here we have 5Fe3 plus 3Mn2 plus 12H2O. Okay, well, let's check whether the equation is balanced. We have 5 this, 5 that is very balanced. You have 24, 12 times 2, 24 balanced, 3 Mn, 3 Mn, 12 oxygen here. I think we have 12 balance. Let's check the ionic charge. Ion here is 0, multiplied by 5 here, plus 24 multiplied by 1, plus 3, and this is equals to. Okay, equals to 5 times plus 3, plus 3 times plus 2, plus 12 times 0. 5 times 0 is 0, plus 24 minus 3. 0 plus 24 is 24, minus 3 is 21. So you have total of 21 charge here. Let's see if we have this side the same. Here we have 15 plus 6 plus 0. So we have here plus 21 plus 0 is plus 21. So both sides of the divide is balanced both atomically and then ionically. You can pause the video and try a redox reaction involving Cr2O7, 2 minus plus Cl. Okay, I have 2Cr3 plus Cl2. You can actually pause the video and see if you can do this. Just the way this is solved. And that is to say that you are actually good to go. That is how we balance redox reaction in acidic medium. Remember that in this reaction, it involves an oxidizing agent, or it involves reduction and then oxidation going on at the same time with this particular reaction. So if you pause the video and see if you can do it, or rather if you cannot do it, you can state your comments or go to where we do more of this in our past question section. Okay, that is all for redox reaction in acidic medium. And then I would like to give us some of reactions, types of chemical reactions that are